Hello there. So in this video, we're going to illustrate rational algebraic expressions and find every value of the variables in that makes a rational expression undefined. So first is we define what is a rational expression. So from the word ratio, so we define a rational expression as an algebraic expression in the form of P over Q, where Q is not equal to 0. So once our Q is equal to 0, so when Q is equal to 0, that's the time we call this rational expression as undefined. Okay, so rational expression, well, since this is an expression, it consists of variables. So for example, I have here x minus 3 over 2x plus 1. Okay, so this is considered a rational expression since I have here my p, okay, x minus 3, over, I have here my q, 2x plus 1. And according to the condition, q must not be equal to 0. So 2x plus 1 definitely not equal to 0. So this is considered a rational expression. Now, let's take a look at this table. Okay, so if I have here a value for x, okay, let me change my color. So if I have here x, okay, x minus 3, 2x plus 1, then I have here x minus 3 over 2x plus 1. Okay, so if I'm going to write values for x, say start with 0, okay, 2, 50, then 1000. Okay, so if I'm going to substitute 0 in x minus 3, so 0 minus 3, that would be negative 3. Okay, 0 substituted in this expression, that is equal to 1. So x minus 3 over 2x plus 1, that is simply negative 3. Okay, now for number 2, for x is equals to 2, so this is negative 1. So 2 minus 3, that is negative 1. So here 2 times 2, that is 4 plus 1, this is 5. Okay, so divide, so that would be negative 1 over 5. Okay, so how about 50? So if I have 50, okay, so that would be 47. 50 minus 3. Then if I have 50, this will become 101. So here I have 47 over 101. Okay, how about 1000? So here I'm going to have 997. Okay, then here I'm going to have 2000 plus 1, so that will be 2001. Okay, and then divide 997 divide 2001. Okay, so if we're going to get the decimal number here, or the decimal representation, you will notice that as x gets larger, okay, therefore the value of x minus 3 over 2x plus 1 is, okay, increasing. Okay, so this is increasing. Okay, so well, if I'm going to get, or if I'm going to have a value for x that is 1 million, so you could say that is, the answer would be approaching, okay, infinity. Now, so again, we define a rational expression as, okay, so an expression that can be written in the form P over Q, where P and Q are polynomials in one variable, and Q is not equal to 0. So other examples of rational expression, so you have here 4 over x minus 2, 4x over x squared minus 9, then I have here x squared plus 2x minus 35 all over 3x plus 4. So these are examples of rational expression. Now, we can evaluate or rewrite rational expressions. So remember that in evaluating algebraic expressions, we replace the variables with the given values and then simplify the resulting expression. Okay, so for example, we have here, okay, I have here x squared minus 3 all over x minus 2. So have here for A, I have here x equal to 0, and for B, I have here x equals to 1. So all I'm going to do is to substitute the value of x in this algebraic expression or rational expression. So it will become 0 squared minus 3 all over 0 minus 2. Then simplifying, 0 squared is 0 minus 3, that would be negative 3 all over 0 minus 2 is negative 2. So you have here two negatives. So since both of the numerator and denominator is negative, so the answer would be 3 over 2. Okay. Now, how about for x is equals to 1? So same solution. So I'm going to substitute 1 into x. 1 squared minus 3, that is all over 1 minus 2. So I have 1 squared, that is 1 minus 3, that will be negative 2 all over 1 minus 2 is negative 1. And again, both are negative, so it will cancel out. So the answer would be 2. Okay, now, how about you try this one? Okay, so how about x squared minus 5 all over x minus 1? So for letter A, you have x equals to 2. For letter B, you have x equals to negative 1. So it's for you to try. Okay, now, so like what I've said a while ago, okay, so we will going to have an undefined rational expression if our denominator q is equal to 0. Now what we're going to do is we're going to find every value of the variable that makes the expression undefined. So simply put, we're going to get the value of the variable that makes the denominator equal to 0. Okay, so for example, I have here 2a squared all over a minus 3. So I am after with the denominator being 0 to be considered it undefined. Okay, so all I'm going to do is, well, simply by inspection, the answer would be positive 3. But by solving, okay, so this will be my q, okay. So since this is my q, okay, I'm going to equate that to 0. So a minus 3 is equal to 0. And simply transpose negative 3 on the other side. Then you have a is equals to 3. So if I'm going to substitute 3 in the denominator, okay, a is equal to 3. So you have 3 minus 3 and that would be equal to 0. Therefore, this rational expression is undefined. Okay, another example is that if I have here 7 over x minus 2 x plus 1. Okay, so what makes my denominator 0 is, what I'm going to do is I'm going to equate the denominator into 0. Okay, so that would be x minus 2 is equal to 0. Transpose to the other side, that would become x is equals to 2. On the other hand, that would be x plus 1 is equals to 0. Transpose to the other side of the equation, and that would be x is equals to negative 1. So if I'm going to substitute 2 in the denominator, that will be 2 minus 2 and it will become 0. 0 multiplied by any number will be 0. Same with this 1. Okay, now, another example. what if I have here, okay, 3a plus 4b all over, okay, a minus b. Okay, so again, I'm just going to apply the same process. So I'm going to equate this into 0. So simply transpose negative b to the other side of the equation. So I have here a is equals to b. Okay, so that would be my answer. Now, it's your time to try this one. Okay. So how about for, let's say you have, for letter A, you have 3x squared all over x plus 3. Oops. X plus 3. For letter B, you have 2 all over quantity x plus 3, x minus 3. And for letter C, you have c all over a minus c. Okay. So, I hope you find the illustration of rational expression easy. So for our next video, we are going to simplify rational expressions.